My name is Mota from ACG Research. I'm the CEO and principal analyst for ACG. We focus on the service provider space, and we do everything from quantitative analysis to service creation and economic modeling for a lot of service providers around the world. I think initially when you look at the service provider, what's happening globally is you're seeing the traffic being somewhat unpredictable, where in the past it was very predictable and you were able to develop architectures to match that area, right? So the adoption of having, something that you could deploy that's scalable, that's very cost effective because of some of the economic climate. You need to have something, but be able to have some merchant silicon so you could go to market quicker, because what's happening at the pace that enterprises are moving is move from slideware of digital transformation to reality. And these service providers need to be able to catch up and adapt, and merchant silicon is a quicker way to get to market from that area. Now, one of the interesting things regarding merchant silicon diversity that we see in the market is primarily two things that I see. It's globally from a supply chain point of issue. If you have a limited number of vendors, you're going to have limited capabilities to be able, and that created a challenge because some of the delays of shipping this equipment created business continuity globally. The other part is what I call innovation stagnation. And because of that area, right, if you're limited to these number of vendors, your business priorities are driven by their requirements like that. So you need to be able to have more diversity in the market, and that's a big problem. Those are the two biggest problems that I see with diversity in this area. One of the things that we see initially is that a lot of service providers went to adopting more of a consumer-based 5G, and they found out that their CapEx investment hasn't been recouped because their ARPU remains the same. Some had a little bit of a spike, but when they had competition, so therefore they needed to focus on expanding their total addressable market. And whether it's enterprise 5G or that particular area, we do see certain pockets of in the enterprise space regarding real-time streaming, whether it's telemedicine, education, which is an important part of it. The other part is what we see where industrial automation, we see a lot of parts where you can even do a business case, because if you have certain latency requirements, it's a matter of life and death in the area. And a lot of the applications, what we see globally, is moving closer and closer to the edge in that area. And because of that particular need, you have certain things where there's self-driving cars and other areas. So what you see with a lot of service providers in these particular areas, they're really trying to find a market where they call it enterprise 5G or private 5G, of expanding their TAM, but be able to recoup their investment. And you are seeing more and more pockets of those requirements going across the board. So what are some of the enterprise 5G requirements that you see in the particular market? Initially is the low latency. Now, low latency you can do in 4G by tweaking it a little bit, but what you lack is the capability to have the QoS capability. So you need to be able to offer low latency without compromising the quality, like I said, because if it's a vertical, whereas an IoT for railway or some industrial automation there, you can't afford to have the latency there. So it's regarding latency. The other part is service assurance, right? When it gets to service assurance, you're not look at just one component. You need to look at the end-to-end service part of it and make sure it's reliable. And the service provider needs to have the visibility of that, right? Because they're the ones getting the phone call that something's not working in that area. And without that lack of visibility, it's hard for them to be able to do that, right? And then reliability is very important in this particular area, because whether it's telemedicine or remote robotic type surgery in those areas, they can't afford to have any latency in this market there. So what are the key takeaways from what I see from the Nokia announcements regarding the SRX event? I kind of break it down into 3 or 4 type areas. Initially, I talked about the silicon part of it, where if we look at the FPCX area, right, it addresses a part in the market, right, which is the access aggregation space. In that area, it needed to have new changes because the merchant silicon just couldn't address the demand. I talked about where traffic is moving closer and closer to the edge. So there's a need to be able to have a cost, reliable, scalable, secure part of it, right? And it's able to do 5 terabit, which is a nice requirement. It's able to handle the power efficiencies, about 0.1 watts per area, but it addresses some of the security issues regarding max sec on every port and any sec capability to address on top of it, which I think, so I think the part of the chip is very important because it addresses some of the criteria to service provider. The other part is related to the SR Linux platform, is that you can't keep continuing to build networks the same way you have before. We need to learn from what the hyperscalers have done and be able to create this scale up and scale out capability. So the SRX allows an open platform, fully programmable, that allows the service provider to be able to differentiate and create innovative requirements for the areas. And the other piece is with the NSP, when we look at the controllers, you need to have a flexible controller to be able to address all the components to deliver that service point of view. And then with the 7730 type product, in this particular area, it kind of completes the product by having something to insert into the access aggregation now. I see this potentially going across multiple domains into that area across the board there.